in the flyer. So let me take you to the flyer. Okay, so let me share the screen. Okay, just a second. Let me take you to the flyer first so that, okay, just a second. Okay, so this is the flyer. Yes. Yeah. Okay. So today is day 1, that is 27th. So in the first session, we are going to talk about structure equation modeling introduction and the difference between covariance based SEM and PLS-SEM, and what are the considerations when should you go for using PLS-SEM. And in the second session, we are going to talk about model building, how to build a model that is researchable, that is relatable, and that really contributes to research. And we are going to focus on the conceptual and theoretical underpinnings and formative measurement model, all those things, and reporting and other issues. So, and similarly, day second, day third, day fourth, and day fifth. In fact, this is a workshop which is spread in 2 phases. So the first phase will cover most of the topics in PLS-SEM. In fact, how to run a model and formative constructs on reflective constructs and how to estimate model parameters and all those things. And in the later part of the session, that is from 4th to 5th of January, we are going to see all advanced modeling, mediation, moderation. In fact, mediation and moderation will start tomorrow, day after tomorrow itself, and then we'll focus on the advanced issues in PLS-SEM, that is model robustness checks. And this everything we will be doing in R. I'm not going to touch Smart PLS4. In fact, Smart PLS4 is the latest version which has been launched, and Smart PLS4 is that much advanced that it has incorporated AMOS also. In fact, you can run covariance based SEM in Smart PLS4. So, but here we are going to use only R, which is an open source and free software. Okay. So let me set the ground rules for this session. There is no wrong question or there is no bad question. Whatever question that you have in mind, you better ask. I would be happy to address all your queries. Now, this is an advanced workshop, and I presume that after this workshop, you will be start using R, and you will be using PLS-SEM also in your research. Yes. So let us begin. Let us begin. So this is a PPT that I have prepared for you. Let me just change the settings. And Manishji, can you just manage the voice? Yes. Hello.
Yes, Arunji.
Yeah. Am I audible to you?
Yes.
Yeah. Okay. So let's start. Structural equation modeling. Yes. In fact, there are 3 terms: structure, then there is equation, and there is modeling. In fact, when I talk about structure equation modeling, there are a series of equations behind the model. Manishji, I can see some disturbances, or I can hear some disturbances. I think new audiences are joining, and
Certain. So they are.
okay. Okay. So let's begin with the origin of SEM. So it has a fairly decent history. So if I talk about SEM, so the root goes back to 1904, when Charles Spearman he introduced the concept called factor analysis. Now, when I say factor analysis, it means let's say you have 20 observed variables. So those observed variables can be reduced to 2 or 3 factors. Now, there might be n number of items to measure something, but all those n number of items will not make meaning unless it is reduced to 2 or 3 factors. So Charles Spearman, he was a British psychologist, and in 1904 he came with the concept of factor analysis. So the origin of structure equation modeling goes to 1904, and later on lot of developments happen. So it's always interesting to see the history of a particular topic. Then things becomes very clear. So now Spearman was working on the intelligence theory. So now when I talk about intelligence itself is a debatable topic. So Spearman, he identified all factors that leads to intelligence, and he came out with 2 factors. That is known as 2-factor theory on intelligence. One is general factor, and another is the specific factor. So that is how he reduced more than 20 variables into two factors. And he came out with two-factor theory on intelligence. Then again, what is factor analysis? So it is a method to explore the underlying latent variable. See, whenever we do research in psychology, or for that matter, social science, the construct that we have, or the variable that we have, it is always latent. Now, when I say latent, it means it cannot be observed directly, or it cannot be measured directly. So it has to be measured in an indirect way. So now, in fact, one interesting thought goes that why to use SEM? Yes, when regression is there, when analysis of covariance is there, or ANOVA is there, and so many other types of regression is there. Why to use SEM? See, the speciality of SEM is that it can model latent constructs. When I say latent constructs, constructs which are hidden, which cannot be measured directly. Let's say if I talk about intelligence now, how does one measure intelligence? It is, intelligence cannot be measured with just one item or two item. Maybe you need to ask a lot of questions to a respondent, then you'll get to know how intelligent a person is. Now, take for that matter other constructs in social science, like leadership, organizational identification, organizational citizenship behavior, or let's say impulsive buying tendency in let's say topic in marketing. So there are so many constructs which cannot be measured directly. So a construct or a variable that cannot be measured directly is always a latent. And to measure a latent construct, you require n number of items in order to find out that latent construct. So here, if you focus on the third line, it says factor analysis provides a method to explore the underlying latent variable that might influence other variables. So there is one hidden variable and which is impacting other variables. So that is essentially the idea of factor analysis. Now, so again, then in 1920s, exactly after a span of 16 years, uh, Sewell Wright, he came with the concept of path analysis. Now, when I say path analysis, it is nothing but relationship from one construct to the other construct. In fact, that's where regression lies. So factor analysis, path analysis together, they summed up as structure equation modeling. So to proceed further, again, then later developments came in 1970s when Carl Joreskog and Doc Sobon, they started working on this structure equation modeling. So to proceed further, so there are softwares. Let's say in 1980s, Joreskog he came out with this software known as Lizrel, and it was very popular before IBM Amos came into picture. So now software packages like Amos, EQS, and M Plus, they became quite handy to run and test complex models. So if you talk about again now, what is the use of SEM? If you focus on this particular line, so the speciality or the beauty of SEM is that it can model complex relationships. Now, when I say complex relationship, let me see. If I talk about SEM, it's a second generation statistics. Now, in order to understand second generation statistics, you need to understand what is the first generation statistics. So if I talk about first generation statistics, here comes your regression. Here comes your ANOVA. Here comes your logistic regression. Yes, the difficulty with the first generation statistics, let's say regression, was that you need to have one dependent variable and more than one independent variables. But when it comes to SEM, you can have more than one dependent variable and many predictors. So SEM can model complex relationships. In fact, you must have heard about Professor Hayes, and he has came with his own plugin, which is known as Process Macro. In fact, Professor Hayes has given 70 plus models. So now, if you're using this mediation, moderation, and conditional process analysis, if you are doing in your research, and if you follow the Hayes model, Hayes has given us more than 70 models, and it starts from a simple mediation model to conditional process model, and there are a number of models. So the beauty of SEM is that it can model complex relationship. You can have more than one independent variable. You can have more than two dependent variables and many predictors. So it has gained popularity across disciplines for its ability to model complex relationships among observed and latent variables. Again, SEM comes into picture when you have latent variable. When I say latent variable, it is that variable which cannot be measured directly. So it allows researchers to test and refine theoretical models, understand causal relationship, what leads, let's say A leads to B or B leads to C. So causal relationship, it is easily factored by SEM, and it also helps us to estimate direct and indirect effects. I'll tell you one interesting thing, like let's say if you want to test mediation, earlier when people were testing mediation, they relied on Barron and Kenny 4-step approach. So it was a 4-step approach where you try to identify the mediation in the model. Yes, but now SEM, it can factor many mediations. In fact, it can take care of simple mediation, serial mediation, parallel mediation. It can take care of all mediations, as well as direct effect. It is of course it can model, but indirect effects also SEM can effectively model. So that's how the history of SEM. So the history of the SEM goes to 1904, and in 1980s, since 1980s till today, SEM is very popular. But Major Philip SEM got in 1980s when Joreskog and Herman Wold, they wrote their first paper in 1982, and that became a seminal paper. And since 1982, SEM is very popular. In fact, if you read any paper in marketing, or for that matter paper in organizational behavior, you come across that SEM is used very heavily by the research scholars. Because why? Because there are certain relationships which are hidden, and they are working with latent variables. So SEM takes care of all those things very easily. Now, as I said, that be it any discipline, psychology, economics, marketing, finance, biology, SEM is useful for testing and validating theories. You can test theories, you can validate theories, as well as you can understand the complex relationship among the variables. Let's say whatever model you are testing, yes, SEM allows you to estimate the various relationship, be that relationship be a direct relationship or indirect relationship. SEM is going to model all those things, and it is going to help you to test hypothesis. So in short, let's say if I have to sum up what SEM is, so SEM is combination of psychometrics and econometrics. Now, when I say psychometrics, it is your factor analysis. And when I say econometrics, it is your regression, predominantly multiple linear regression. So again, let's say when you measure a certain construct, let's say you use established scale and you measure a construct. Now, there are times where you can where you need not rely on SEM. You can simply aggregate the observed variables, or you can average the average variables, and you can run a regression. Fine. But are those constructs valid? Are you measuring what you are intending to measure? Let's say if you want to measure a person's intelligence. Now, intelligence cannot be measured with the length of the hair. Yes. So if you want to measure intelligence, you have to ask a pertinent question to the respondent, so that you get to know that yes, whether a person is intelligent or not intelligent. So when it comes to validity, let's say you measure a construct, but are you measuring what you're intending to measure? Let's say, let's take example of construct like success, happiness, leadership, or let's say organizational identification, or say organizational citizenship behavior. Now, let's say you are using 20 items to measure, let's say, leadership. Now, are you measuring leadership, or you are measuring something else? Now, remember, whenever you circulate your questionnaire uh, to the respondent never knows that he is answering a construct. A respondent always answers the item. Let's say you put all your questions in a Google form or a Survey Monkey and send it to the respondent. The respondent never knows whether he's answering what he's answering. A respondent always answer a statement. Now it is you who, as a researcher, go and club certain items and say these 5 items together make up this particular construct. So the participant, or the sample in your research, is always unaware as to which construct you are measuring. Now, it can so happen that you feel that you have measured a construct but in fact you have not measured actually what you were supposed to measure. So that's why SEM takes care of validity. Now, when I say validity of the construct, it means the construct is measuring what it should measure. So when I say psychometrics, it takes care of your validity. Now, in structure equation modeling, there are two validity which is very, very important. One is your convergent validity, and second is your discriminant validity. So that's why validity assessment is part of psychometrics. And when I say econometrics, this is your path modeling or the relationship between two constructs. Let's say happiness leads to success, or satisfaction reduces turnover intention. So econometrics is your regression, multiple linear regression. So if I go further, so psychometrics, it is your CFA. Now, confirmatory factor analysis is also known as theory testing or measurement model. Let's say a scale developer has given you a scale, let's say a 10-item scale to measure success. Yes. Now you use somebody else's scale, a developer scale, and you are measuring success. Now you need to test this scale whether the scale is as per the theory or not. That's why whenever you say confirmatory factor analysis, this is your theory testing. This is your theory testing, and it is also known as measurement model. Is that fine? Hello? Are we on the same page? Yes?
Yes, yes, yes.
Yes, sir. Yes, sir.
Yes,
Yes,
sir.
sir.
If any query you have, you ask me, stop me, I'll be happy to answer. So psychometric takes care of your validity, and econometrics is your regression. Regression, again, it's very simple. We'll see that equation. It's very simple. Again, psychometrics constitutes confirmatory factor analysis. If you read any standard paper where SEM is applied, you'll definitely come across this confirmatory factor analysis. And in confirmatory factor analysis, you try to address the validity concerns. Validity. When I say validity, it means you should measure something which is accurate and which is perfect. Yes. In the name of happiness, you can't measure something else. In the name of success, you can't measure something else. So confirmatory factor analysis, it's essentially validity testing. And there are two kinds of validity. One is convergent validity, and second is discriminant validity. Definitely we'll see this in detail, but as of now, this is just we are setting a tone into context. So just flow with the flow. And again, as I said, econometrics, this is your multiple linear regression. Econometrics also takes care of path modeling. When I say path modeling, definitely you will run a regression and you'll try to find a relationship between the constructs. In fact, multiple linear regression becomes the base for testing the hypothesis which you have proposed in your model. Is that fine with you? Okay, so let us proceed. Let me hide this notation. People are joining late and this notation is propping up. Okay. So just a second. Okay. So now approaches to SEM. Now this workshop is on partial least square structure equation modeling. You call it PLS-SEM, PLS-PM, PLS-PM, or composite based SEM. So it is known by different name, but as you all know that SEM broadly is part of there are two families of SEM. And SEM, as I said, it's a second generation statistics. So there are two popular approaches. One is covariance based SEM, and second is your PLS-SEM. So this workshop will be focusing on PLS-SEM, which is nothing but a non-parametric approach to structure equation modeling. Let us go further. So when I say CBSEM, it is used to confirm what is the use of CBSEM, or why people go for covariance based structure equation modeling. In fact, these days PLS-SEM is getting a lot of popularity. You come across n number of papers where people are heavily using PLS-SEM. Now, one question will come to your mind, that why people are using PLS-SEM and why not CBSEM? In fact, CBSEM Just CB-SEM is popular. I'm not saying that it is not popular, but you see now increasingly lot many research scholars are tilting towards PLS-SEM. So now there are situations where CB-SEM has to be used, and there are situations or there are circumstances where PLS-SEM has to be used. Now that line and the difference between these two approaches to SEM, it is getting blurred. In fact, now people are using CB-SEM and PLS-SEM interchangeably. So where CB-SEM was required, now people are using PLS-SEM, and where PLS-SEM was required, people are using CB-SEM. So now they both these approaches to SEM, they are complementary to each other. I'll show you a couple of papers, and in fact, I have send you few papers. Though I had lot many papers to send, but I wanted to avoid the problem of plenty. If I send you too many papers, then ultimately you will end up reading few papers. Or if I send you few papers, you will read those papers at least in detail. This is what I presume. So what is the use of CB-SEM? It is used to confirm or reject theories. Let's say a theory which is already established. Now, drawing inference from that theory, you came with your own model. Now you want to test this theory, you want to validate this theory. So let's say if your goal as a researcher is to validate or confirm a particular theory. To put it simply, let's say social exchange theory. In your model, you want to test a social equation theory. So let's say if your goal is to confirm or reject theories, then CB-SEM is the preferred option. That's why this approach confirms rejects hypothesis by determining how closely a proposed theoretical model can reproduce the covariance metric from an observed sample data set. I mean, if your goal is to confirm theory or validate a theory, people go for CB-SEM. Now see, when I talk about CB-SEM, you always come across model fit indices. In CB-SEM, you see, if you read a standard paper where CB-SEM is applied, people report on model fit indices. Now, when I say model fit indices, it means people report all this goodness of fit, normed fit index, Tucker-Lewis index, and goodness of fit. There are so many indices which people report. Now, see, what is the idea of CB-SEM? Now, whenever you specify a model, now, when I say specifying a model, it means whenever you draw a model, let's say A leads to B and B leads to C, a simple mediation model. A leads to B and B leads to C. And now, whenever you draw a model, what is the assumption in CB-SEM? CB-SEM will take that model as a true model, and it will produce a covariance matrix. Yes. And then the data set that you have, the data set, let's say you have a sample of 250 respondents. So whatever model that you draw in CB-SEM, it is considered to be a true model, a genuine model. The software will say, okay, this is the reality. Yes. And then out of your sample, the software is going to generate a covariance matrix. So let's say when you're using Amos, so how the software goes about it. Just don't mind me. This is a theory class, and in the later part, I will definitely and there are a lot of diagrams which are to be drawn, and I'll use this Microsoft whiteboard and make my session more interesting. But please try to understand what is the idea behind CB-SEM. So let's say you have a model, a simple mediation model. A leads to B and B leads to C. The software, let's say Amos will say this is a true model. Okay. So it will produce one matrix. And let's say when you put your data into the software, the software will generate a covariance matrix. So there are two covariance metrics, one covariance matrix for the original model and one covariance matrix which is based on your sample. Yes. And then in CB-SEM, the software will try to fit the original model with the sample model, and it will try to reduce the discrepancy. Yes. So that's why whenever you use CB-SEM, yes, the goal is to minimize the discrepancy between the true model and the model generated by the sample. And that's why you have all this model fit indices. But when you talk about partial least square structure equation modeling, model fit indices is hardly to be seen. However, of late, post 2015, Hensler and all, they are working on model fit indices in PLS-SEM also. I will show you a couple of papers now where people are reporting model fit indices in PLS-SEM also. But the goal of PLS-SEM is not to confirm or reject theories, or for that matter to say that I have a decent model fit. In CBSEM, people definitely report model fit indices. There are goodness of fit and there are badness of fit. RMSEA, SRMR, people report all these things, and they say, yes, I have achieved a model fit. But in PLS-SEM, there is no concept of model fit, but of late, people are talking about model fit indices in PLS-SEM also. Yes. So the goal of this workshop is not CBSEM, but yes, I will give you a little understanding of CBSEM, and the more focus will be on the variance-based approach to structure equation modeling, which is your PLS-SEM. Hope this much is clear. So maybe let's say after half an hour, I'll open the floor. We'll take one or two questions, and let this session not be a monologue. It has to be a dialogue where there has to be a two-way conversation. And in fact, if I complete this slide, we'll definitely have a conversation. And there are interesting things that are to be explained in this particular workshop. So what is PLS-SEM? It is known by different name. Okay, so let me use my Microsoft whiteboard so that my session doesn't become a monologue, it becomes a dialogue. Yes? Okay. Yes. So when I say PLS-SEM, yes, it is known by different name. People also call it as PLS-PM, or for that matter, variance-based approach to SEM. Variance-based SEM or composite SEM. Composite SEM. So whenever you see this term, let's say PLS-SEM, PLS-PM, variance-based SEM, or composite SEM, we are talking about partial least square structure equation modeling. By the way, what is PLS? See, there is a term called PLS. Yes. Now, please remember, PLS is an algorithm. Is an algorithm. Hope my spelling is correct. Okay, you can correct it. So PLS is an algorithm. Now, when you use CBSEM, the algorithm is MLE method. That is maximum likelihood estimation. So in CBSEM, the algorithm is maximum likelihood estimation. In PLS-SEM, the algorithm is partial least square. Now, why these two algorithms? Let me come to this particular slide. Why these two algorithms? In fact, how do you estimate the latent variable in SEM is very different in CBSEM and PLS-SEM. So let's say if you are using CBSEM, you estimate the latent variable using MLE method. And if you are using PLS-SEM, you estimate the latent variable using partial least square algorithm. So there is a difference in algorithm, and there is a lot of controversy as far as how do you estimate latent variable in SEM. There is a lot of controversy. In fact, there was one journal, and the name of that journal is Journal of Operations Management. Couple of years back, if you use PLS-SEM in your paper, and if you send your paper to Journal of Operations Management, the editor will test reject it. Yes, straight away your paper will be rejected if you have used PLS-SEM. Yes. So there was a lot of controversy and people said that PLS-SEM is not a correct way of structure equation modeling. In fact, a big fight has happened, and the developers of PLS-SEM, they came with their own arguments, and they refuted all the criticism which were heard on PLS-SEM. In fact, the people who criticized PLS-SEM, they also call it as a poor man's structure equation modeling. यानी ये गरीबों का structure equation modeling है. Yes. So controversies aside, and today people who were criticizing PLS-SEM, now they have come out in support of it. In fact, the latest software that you see for PLS-SEM, which is Smart PLS 4, it is taking care of CB-SEM also. So there is one software which can handle PLS-SEM as well as CB-SEM also. But see, what is the approach of PLS-SEM? It is a causal predictive approach to SEM. When I say causal predictive approach to SEM, the purpose of PLS-SEM is to maximize the variance in the dependent variable. Yes, the purpose of PLS-SEM is to maximize the variance. It means PLS-SEM focuses on maximizing the R square. Now, what is R square? We'll come to it. What is R square? R square is coefficient of determination. I will use R and show you the R square and what will be your contribution in relation to R square. We will discuss once this theory gets over. So let's say if your goal is to confirm or reject theories, use CB-SEM. And if your goal is to maximize the variance in the endogenous construct, or let's say dependent variable, then you should use PLS-SEM. But again, I said, now the line in most of the research is getting blurred, or that line is not that big, and people are using CB-SEM and PLS-SEM interchangeably. You'll come across a number of papers. I'll show you a couple of papers where people have used PLS-SEM for large data set as well. But just remember, if you want to maximize the variance in the dependent variable, or let's say if you want to maximize your R square, then PLS-SEM should be your focus. So again, as I said, see, what's the fundamental difference between CB-SEM and PLS-SEM? If you ask me what is the fundamental difference, it is how you estimate the latent construct. So CB-SEM uses MLE method to estimate the latent construct. PLS-SEM use PLS algorithm to estimate the latent construct. And how you estimate the latent construct, there are a lot many controversies, but now all those controversies are down, are at its rest. Now there is no more controversy. In fact, PLS-SEM is so dynamic that even today people are coming with advanced methodological issues in PLS-SEM. It is very, very robust. I will not hesitate to say that as far as CB-SEM is concerned, you hardly find any new developments, or developments are okay. There are fairly not that great developments which are people are talking about. But PLS-SEM even today, even if you Google it out, like Journal of Information Management or some other Journal of Business Research, people are coming with latest developments in PLS-SEM, and this makes PLS-SEM more dynamic. If I can take you to a couple of papers, you will understand that what are the recent developments in PLS-SEM is. So in fact, it's just food for thought, and even if you don't understand, relax. Once I start using R, it will be a cakewalk for you. And I promise once this workshop gets over, you will be on your own toes as far as running of PLS-SEM in R is concerned. Am I able to? I'm not able to. Okay, just a second. So if I focus here, so just a second. Yeah, I think this is the paper. Yeah. So I recently came across this paper. So it talks about improving PLS-SEM use for business marketing research. Now, see, people say that, I'll tell you a couple of arguments that researchers write in their research paper as to why they use PLS-SEM. First argument that people use or write in their research paper in defense of PLS-SEM is that limited sample size. My sample size is 250, or let's say my sample size is 180 or 220. So my sample size is limited. That's why I'm using PLS-SEM. See, PLS-SEM is designed to work for limited sample size, no doubt about it. But here the author says that if you simply say that you have a limited sample size and because of which you are using PLS-SEM, then this is a nuanced argument. This is not a valid argument. Come out with some better arguments or better explanation as to why you are going for PLS-SEM. In fact, wherever, let's say in top-notch journals, wherever people are using PLS-SEM, they write one para in defense of PLS-SEM as to why they are using PLS-SEM. People write one para, at least one para they write that why they preferred PLS-SEM over CBSEM. So first argument which people write in their papers, people say they have a limited sample size. Second, people say that their constructs violate the multivariate normality assumption. Their constructs, or let's say their model, violates their multivariate normality assumption. This is the second argument which people give. Yes, and third, people say that I have single item in my I have a construct in my item which is measured using a single item. Fourth argument which people give is that the relationship in my model is very complex, so that's why I have gone for PLS-SEM. I'm not using CBSEM. So now when I came across this paper, so there they are refuting all those arguments. They are saying simply you cannot say that my model is complex, I have a limited sample size, or I'm using a single item construct, that's why you should use PLS-SEM. Give a plausible argument as to an appealable argument as to why people as to why you are using PLS-SEM. So if you read this paper, so there it talks about here when to use a PLS-SEM approach. So let me read a couple of lines for you. So since there are different SEM approaches, most prominently PLS-SEM and covariance-based SEM, business marketing researchers need to determine which approach to use. First of all, determine which approach to use. And here you can see the name of Ronco and Everman. Ronco, in fact, Ronco was a hard critic of PLS-SEM. He came with his own arguments and he refuted that PLS-SEM is nonsense and it is not a structure equation modeling, and its use should be discontinued unless the developers come out with the questions that I have raised. And that's why I've given you that paper. If you get time, just read it. And then 10 authors came together and refuted all the Ronco and Evers argument, and they addressed all the concerns of Ronco and Evers, and they said PLS-SEM is a dynamic and a nice version of SEM. You should not water it down. So here, if you read this paper, they are talking about, see, when estimating the model regardless of SEM technique used, this generates proxies of the construct based on the available data of observed indicators. In fact, I have just highlighted based on my wherever I felt like highlighting it. But you read this paper, you'll come across that when to use PLS-SEM and when to use CBSEM. See, again, I said the controversy in PLS-SEM and CBSEM is it's with regards to the estimation of the latent construct. Yes, how do you estimate the latent construct? So again, as I said, PLS-SEM is also known as composite based SEM. So in PLS-SEM, the latent construct here actually you don't estimate the exact latent construct, you generate proxies. In PLS-SEM, the algorithm, it generates proxies. And critics say that this proxy is not a latent construct. And that's why the criticism start. So we'll discuss that all these things. So I have marked it here and there. You just read it, that what are the arguments that need to be used when you are using PLS-SEM instead of CBSEM. Again, if you focus here, I have marked in yellow. PLS-SEM and CBSEM application usually differ regarding how they use the observed indicators to create construct proxies. Yes, you are creating a proxy of a construct, but the approach is different. So PLS-SEM applications specify construct proxy as a composite. So in PLS-SEM, the latent construct will be modeled as composites. When I say composites, it means there are no errors associated with the measurement. Yes. When I say composite, it means it is an error-free measurement. There are no errors as far as the estimation of the latent construct is concerned. Again, this is a high level discussion, but I would suggest you to read this paper and use some of the argument as to why you use PLS-SEM instead of CBSEM. Okay, so now let me come to this slide. Okay, so again, the fundamental differences with regards to the estimation of the latent variables, how you estimate latent variables. So in PLS-SEM, you use composite method. That's why it is known as composite based SEM. When I say composite, it means you generate proxies of the latent construct, which is considered to be a true score. Okay. So now again, this was a paper which came out in December 2018. When to use and how to report the results of PLS-SEM. In fact, since 2018, lot many developments have happened. But even if you read the uh, uh, a book on PLS-SEM, a primer on partial least square structure equation modeling, in that book itself, the authors have given a reason as to when you should use PLS-SEM. They have came out with arguments that if this is the case, you should use PLS-SEM. If this is not the case, you can go for CB-SEM. So this is one paper. The arguments of this paper, or the arguments provided by the author in defense that when you should use PLS-SEM, it is relevant even today. So not much has changed. So here, if I focus, yeah. So these are the grounds. In fact, I have borrowed this entire line. This is a screenshot from that paper. So when should you use PLS-SEM? First, when the analysis is concerned with testing a theoretical framework from a prediction perspective. If prediction is your objective, when I say prediction, it means R square. If you want to maximize your coefficient of determination, if you want to maximize your R square, means if you want to explain your endogenous construct, or if you want to explain or if you want to maximize the variance in the endogenous construct, PLS-SEM is a preferred choice. PLS-SEM is a preferred choice. And mind it, model fit indices is not a characteristic of PLS-SEM. Again, what I'm saying, I will be saying with certain caveats. Of late, the developers of PLS-SEM, they are working on model fit indices. And now papers are also talking about model fit indices in PLS-SEM also. I'll show you a couple of papers. But if your goal is not model fit indices, and if you want to explain the variance in the dependent variable, then you should use PLS-SEM. It means first line says if you want to maximize your R square. Yes. Now, how much should be R square? We'll talk about it. I'll open my R and take one data set, and I'll show you how to maximize R square. When the structural model is complex and includes many constructs, indicators, and or model relationship. Let's say you are working on a complex model. Yes, there are mediators in the model and there are moderators in the model. Now, I don't use much of IBM Amos, or for that matter CBSEM, but there, if you're using IBM Amos, let's say you run individual CFAs, you extract the construct, and then you run a regression, and then you test whether moderation is there or not. But I'll model all. In fact, in the R syntax that I have given you, maybe tomorrow or day after tomorrow, I will show you a complex model. A complex model which can be performed with a click of button in R. So if your model is very complex, let's say there are multiple dependent variables, or there are many independent variables, there are single item constructs, there are formative constructs in your model, and if your relationship is complex, then yes, PLS-SEM is the preferred option. PLS-SEM is a preferred option. Third, when the research objective is to better understand, increase complexity by exploring theoretical extension of established theories. For exploratory research, or let's say somebody has given a theory, but a certain variable is missing. Now you brought that new variable into your model, and you want to test by bringing that new variable in your model, what is the impact on the dependent variable. Yes. So if you want to extend a theory, or you want to build upon a theory, or you want to contribute to a theory, so again, PLS-SEM is a preferred option. So if theory building is your objective of research, then PLS-SEM is a preferred option. If validating theory or confirming theory, a theory is there, you are confirming it with your data or with your research, then CB-SEM is the preferred option. Yes. So all the arguments which was provided in this 2018 paper, they are relevant even today. So that's why I don't say that this is an old paper. Of late, lot many developments have happened, but this argument hold valid even today. Fourth, when the path model includes one or more formatively measured constructs. In fact, when PLS-SEM was built in 1982, the algorithm was built by Herman Wold in 1982. It was this software, this algorithm was made considering formative constructs in mind. Yes. Now there are two kinds of construct. We'll discuss this in detail in the latest slide I have. There are two kinds of construct. One is your formative construct and second is your reflective construct. So in your model, if there are formative constructs, then PLS is king. It can handle formative constructs very easily. If you're using Amos, you know that if you're in Amos also people model formative constructs by adding one more item here and there. But as far as formative constructs is concerned, PLS-SEM is the king. It can model formative constructs very easily because PLS-SEM is nothing but regression. To put it simply, formative construct is nothing but a sort of a regression. I'll show you the diagram of formative construct. It is there. We'll discuss in detail. Yes. So if formative constructs are there in your model, if single item construct is there in your model, PLS-SEM is the preferred option. Okay. Next, when the research consists of financial ratios or similar type of data artifacts, when the research has secondary archival data, again, all this thing, just focus on the third last line. For small sample size, let's say you have a small sample size. In fact, if you read that book, A Primer on Partial Least Square, now what should be the minimum sample size in PLS-SEM? Now, if you talk about factor analysis, it's a large sample technique. You really require a large sample size in CBSEM or let's say factor analysis. But if you read that book, a primer on partial least square. So what is the minimum sample size? It says number of arrows pointed or number of arrows which are there at the dependent variable. Let's say if there are 5 arrows coming to the dependent construct. So 5 into 10, 50 is the minimum sample size. However, this is not a valid argument, and there are many researchers who are questioning this, that number of arrows coming from the independent variable to the dependent variable, that should not be used as a yardstick for determining the sample size. Now there are formulas available. There are G power software where you adjust the settings and then you estimate the sample size. But yes, of late, if you have a relatively small sample size, let's say business to business research where your sample size is 150, 160, 130, PLS-SEM is a preferred choice. So it can handle small sample size. When distribution issues are a concern, such as lack of normality, again in CBSEM, I've come across some of the research scholars where the reviewers have asked a question that you have used CBSEM, but you have not reported the multivariate normality assumption. So go report. Now, whenever you work with Likert scale, or let's say whenever you are measuring your constructs on Likert scale, multivariate normality assumption will be an issue. Your data will not be normal. Yes. Then in that case, a question will be asked that you have not reported the multivariate normality assumption. So report it. So, but when you talk about PLS-SEM, it is not very rigid to all this parametric assumptions. Even if your normality assumption is violated, PLS-SEM will be fine with it. So it is called an assumption-free approach to SEM. There are no assumptions as far as PLS-SEM is concerned. So even if your data is not normal or multivariate normality assumption is violated, PLS-SEM will work perfectly fine with your data, because the goal of PLS-SEM is to maximize the R square. Using independent variable, you maximize the R square. The goal is very simple. So it's a distribution-free approach to SEM. There are no, it's an assumption-free approach to SEM. There are no distributional assumptions. There are no other assumptions which are as rigid in CBSEM. Those are not there in PLS-SEM. That's why PLS-SEM is more attractive and increasingly used, because there are no assumption. You simply have a model, specify the model, and estimate it using PLS-SEM. That's why it is gaining popularity. So when research requires latent variable scores for follow-up analysis, or let's say you are using latent construct and you want to do certain analysis maybe later, or maybe you want to build a new model and you want to test how much R square has improved. So PLS-SEM is the preferred option. Having said all these things, or what the research paper says, if I have to give one word to all the research community, CBSEM and PLS-SEM, now they are complementary to each other. Let's say tea or coffee, both are complementary. If tea is not there, you'll settle for coffee. If coffee is not there, you'll settle for tea. So they both are like tea and coffee. They both are complementary to each other. So now the debate is over, that which one is superior and which was an inferior. That debate is no longer there, and it doesn't hold any water. Both approaches are important, and both approach helps you to test the validity of the construct, and both approach helps you to establish the relationship between the constructs and test the hypothesis. Now there are a lot many simulation studies which have been carried out and which have said that both methods are doing fine. And in fact, of late, there are developers in PLS-SEM. They are going highly critical of CBSEM. In fact, there are papers where people have criticized this common factor model based approach to SEM, that is CBSEM. People are now, there are papers which are written and with simulation studies, and they are criticizing CBSEM, and they say PLS-SEM is better than CBSEM. But having said all these things, don't land yourself in this terrible or hotly debate or hot debates where which one is better and which was an inferior. Don't take any sides and position. Both are complementary to each other. Use it as per your convenience, as per your understanding. Yes. And both approaches to SEM, CBSEM and PLS-SEM, they can be perfectly taken care in one software, that is R. Even if you don't have IBM Amos, even if you don't have Smart PLS, even if you don't have Edenco, you don't have M+, if you have a laptop, you can download R. You can just write the syntax, and you can run any approach to SEM in R. Okay, so let us proceed. Any queries? Manish ji, any queries from any participant? Hello? Hello? Are we on the same page?
Yes, sir. Participants are free to ask, sir. I mean,
Yeah.
they
Yeah,
they
because
should creep in, and if they have any doubt, they
yeah,
can come.
yeah. My session should not be a monologue, and in fact, when I start running R, it will make a lot of sense. And this is
Sir,
this is just a few. Yeah,
I have a small understanding issue. When we
yeah.
go for OLS, we require blue estimates. Are these blue estimates required for PLS as well?
See, first of all, madam, please understand, as I already mentioned, that when you use PLS-SEM, there are no assumptions, there are no blue estimates, there are no model identification issues. If you have a simple model that can be easily tested using PLS-SEM, those blue estimates and all those criteria are not required in PLS-SEM. Is that
Got it,
fine?
sir. Thank you. Yes, yes.
Okay. Again, and Dr. Vaishali talked about OLS, ordinary least square. So one is MLE, one is OLS, and one is PLS. By the way, what are these three things? MLE, maximum likelihood estimation, PLS, partial least square, and third is OLS. What are these three? All these three are algorithm. Now, when you talk about OLS, Dr. Vaishali, see what OLS does. See, OLS will try to minimize the error associated in the regression. That's the goal of OLS. In fact, I'll tell you one interesting thing. If you talk about CBSEM or PLS-SEM, the controversy was with respect to estimation of the latent construct. So you are estimating the latent construct in CBSEM by MLE method and PLS-SEM by PLS method. You are estimating the constructs in a very different way. But later on, you are running a regression, and regression uses OLS method, that is ordinary least square. What is OLS? It tries to minimize the error associated with the prediction. Yes. So regression is common in CBSEM as well as in PLS-SEM. Regression is common, and whenever you use regression, the software is designed in such a way that it goes by OLS method. It tries to remove the error associated with it tries to minimize the prediction error associated with the prediction. Yes. Okay. Any other query? Any other observation? Agreement? Disagreement? Which one is better according to you?
Arun
Okay.
sir, in the chat box, Madam Abha has asked one question, that what does maximizing R square means?
Okay. Maximizing R square. We'll come to it. Let me, in fact, I have that thing in my mind. See, first of all, what is R square? What is R square? See, R square tries to explain the dependent variable with independent variable. Yes. R square is known as coefficient of determination. The more independent variables you bring in your model, your R square is bound to rise. Yes. More number of independent variables, your R square will increase. Now pay attention. Now the question is, what is R square? Or let's say when temperature rises, or let's say when temperature rises, the sale of ice cream increases. You see, in summer season, the sale of ice cream is more than in winter season. So now you can say that temperature and sale of ice cream, they are correlated. There is a relationship between temperature and sale of ice cream. Yes. And let's say you have one variable temperature and one variable you have sale of ice cream. Now temperature explains, let's say the R square is 65%, or let's say 0.065 or 65%. And let me talk in a layman's term so that everybody understands. Let's say my R square is 65%. What does it mean? It means that 65% sale in ice cream is explained by the temperature. It means there is still 35%, or let's say 100 minus 65 is 35%. There is 35% which is unexplained. There is 35% is something which is unexplained. So what is that unexplained? Now, when you say you want to maximize the R square, see, when I say R square is 65%, or when literature talks about that R square is 65%, most of the literature says that about this particular phenomena, 65% is known. So, but 35% is not known. So 1 minus R square is always your contribution to research. Hope I'm making sense. Hope I'm making sense. R square is something that you know, but 1 minus R square is something that you don't know. So as a researcher, you are trying to enter into that territory that is 1 minus R square. Yes. So if your R square is 65%, 35% is still not known. So let's say you bring a new variable into your model. And if you try to maximize the R square, let's say by bringing the new variable, your R square shoots up. It becomes, let's say, 85%. So you have contributed 20% more to that research, or you are explaining something which was not known. So I always say that 1 minus R square is your contribution to research, because R square is something that people know. R square means that independent variable are explaining certain percentage, let's say to the tune of 60% in the endogenous constant. But still there is something which is not known about the something that is unexplained. So in fact, I have a plan in the next session. So I'll definitely use R and show you how to calculate R square and how to maximize all those things. We will definitely see.
So, sir, can I ask one question?
Yes, Sunil, go ahead.
Just increasing R square, it means we are adding, does it mean we are adding some independent variable?
See, of course, your R square will increase if you are adding new variables in your model. With the same number of variables, you can't explain more R square in your model. So let's say you do a literature review and you identify there are certain other variables which were not being studied, or which were not included in the model. So you bring new variables and then you see their impact on the R square. If your R square increases, you say, yes, there is a significant contribution by the new variable to this particular model. Okay.
Yes, sir. Yes.
Okay. So in fact, when I take the advanced part of PLS-SEM, see, if you bring more number of independent variables in the model, R square will definitely shoot up. Yes. But again, there will always a problem of multicollinearity among the predictors. So you have to maximize the R square. But again, PLS-SEM says that R square is a measure of in-sample prediction. R square is the measure of in-sample prediction. R square doesn't explain the predictive power of the model. Yes. Let's say, okay, let me not go into the advanced part. Let me flow with the flow. It will make a lot of sense to you. Let me go ahead. So these are some of the review articles. In fact, you should definitely read some of these papers where almost all disciplines, accounting, construction management, entrepreneurship, HR, knowledge, marketing, operations, psychology. Now there are a lot many review papers which are written on PLS-SEM. That in accounting there are researchers who have used PLS-SEM. So somebody has provided a review of PLS-SEM in all the accounting papers. So similarly, every discipline you find that there are review papers available on PLS-SEM, and these papers are a good source for your understanding. Yes. So I have borrowed this from this particular book here at all. Now let's focus on model building in research and R square and all those things, independent variable, dependent variable, and all those stuff like that. Let me take a whiteboard. Yes. And okay. See, please understand that whenever we build model, we require variables. Yes. We call it variable or constructs. Now, people from maths background, they use the term variable, and people from psychology background, they use the term constructs. Yes. Okay. So now, whenever you build model, please understand you require certain variables. One is your independent variable or variables and your dependent variable. Yes. Now, what are independent variables? They are known by different name. If you read standard textbooks on regression, independent variables are also known as predictors. They are known as predictors. They are also known as exogenous variable. There are many names, but these are the names which are very, very common. Either they are known as predictors or exogenous variable. And your dependent variable is known as outcome variable or endogenous. Okay. So whenever you are building a model, you require, let's say now I'm going to use the term construct. You require constructs. There has to be independent variable or variables, and there has to be dependent variable or variables or construct. So model building in social science research. How do you build a model? So let me ask a question to the whole class. How do you build a model? Then I will proceed further. How do you build a model? Come on. Yes. How do you build a model? First of all, what is a model?
First of all, we have to find what is the impact of something on something,
Okay.
like a dependent variable. In that case, for example, sales depends on like advertisement and like packaging, sales, the person who sells the product.
Okay.
No, different. So in this case, when we find sales depends on these variables, then we can develop a model.
Okay. So to put it simply, so let me come to this. So Mr. Sunil says that let's say sales is my dependent variable. This is my dependent variable. So sales depends upon advertisement. Okay. It depends upon, or what? It depends upon packaging. Or let's say it depends upon product quality.
Quality of product. The person who sells.
Or let's say the experience, or say salesman, experience of the salesman.
Product price.
Very good. It depends upon price.
Yes.
Price. Okay. There are many variables. If I have to put this in equation, I'll say sales is a function of, let's say, price, advertisement, packaging, then quality, and salesman experience. Yes, this is the equation. Okay. So now this is the way you build a model. Now my question is, how do you identify these variables? How do you identify these variables? Let's say you want to build a model.
Literature review.
Okay, so there is, you do literature review. So literature is the classic source. You build model by reading literature. Yes, or you see established theories, what the theory says, what sales theory says, that how sales can be increased, or what are the antecedents to sale. Sale is your outcome variable. It is your dependent variable. And price, advertising, packaging, quality, salesman experience, these are your independent variable. Yes, so you from theory you identify antecedents. From theory you identify antecedents. Anything else? How do you build model other than literature and theory? Okay, so there is something known as observation. People do observations. Now you may build a model based on your understanding. Yes. Now normally when you build a model based on your understanding, or let's say model which is data driven, this is known as a theoretical model. This is known as a theoretical model. It means this is a data driven model. Data driven model. It means not much is known about this particular model, but it's a data driven model. So one is your theoretical model, that your model comes out of a theory. And second is your a theoretical model. When I say a theoretical model, there is no concrete theory attached to this particular model, or data driven model. It's a data driven model, which is a theoretical model. So now when I say model, it is nothing but a relationship between variables. Whichever model you see in journals or papers, every model will talk about a relationship between variables or constructs. Yes. So people build model. So now let's say, now while I was making this PPT yesterday, I proposed a model. There is no theory attached to it, but I want you to reflect what this model talks about. I say notoriety leads to success. Can you relate to it? Notoriety, it means that if you are notorious, let's say in the earlier part of your life, you will be successful later in your life. You will be
So probably
successful.
there is no theory behind this, but we have
Yeah.
seen it a lot of times.
Yeah. Okay. So
And now there are
observation.
different yardsticks to measure success. My
Okay.
yardstick of success might be different from your and
Yeah. Okay.
other people's yardstick of success.
But as a researcher, Dr. Vaishali, you need to define notoriety and you need to define success. That's the challenge and that's the call you need to take. Let's say you are proposing a model that notoriety leads to success. Okay. By the way, there is an interesting theory, marshmallow theory. You should read this theory. This theory is about delayed gratification. So I'll come to it. So notoriety leads to success. Now, for some people, it might be true. For some people, no, this is a nonsense. So as a researcher, now I need to test it. Okay. So first of all, I need to define notoriety. I need to define success. I need to be very clear as to what success is. I need to be very clear as to what notoriety is. And then I need to operationalize it. Again, whenever you build, you see, in quantitative research, you build models and then you test model. So whenever you build a model, first define the constructs and then operationalize the construct. Operationalize means how are you going to measure those constructs? Yes. Okay. Now somebody would say, no, notoriety doesn't predict success. There is something which is missing. So somebody would go and say that, no, I don't agree that notoriety leads to success. In fact, people who are notorious, they are more creative. And creativity leads to success. So there is one missing link. There is one missing link. So okay. So now what this model, can anybody guess what this model is now? It is a mediation model, simple mediation model.
Yeah.
Earlier, there was a thought process that notoriety leads to success. But a new researcher came, said, no, there is one variable which is missing. In fact, notorious people are creative, and this creativity fosters success. So earlier notoriety and success, let's say somebody was asking me a question about what is R square. So earlier, let's say notoriety success R square was 50%. But when I brought a new variable creativity, R square jumps up to, let's say, 60%. So now I am explaining 10% more. That's why I'm saying 1 minus R square is your contribution to research. Somebody said, okay, it's fine that notoriety leads to success. Notorious people are creative and creativity leads to success. Somebody went ahead and said, no, if you're notorious, you're bound to take risk in life. And because of your risk-taking ability, you become successful. How about this model? Does it appeal to you? Does it appeal to you? Okay. So now when you have two mediation in your model, this becomes a case of a parallel mediation. This becomes a case of parallel mediation. Let me take my this. So models in research, it's very interesting. It's a, in fact, there are a lot many debate about how to build model. Okay, so let me discuss how a model is conceptualized. Okay, so let's say, in fact, if you see the R syntax which I've uploaded yesterday, I've taken one more. In fact, I have written the syntax from a theory perspective. Let's say LMX. Now, when I say LMX, this is leader member exchange. LMX is the relationship quality that you have with your leader. If you're working in an organization as a professor or for that matter lecturer, now you will have a relationship quality with your director or with your principal. And that relationship quality will determine a lot of work outcomes. And in fact, this is a theory which was proposed in 1975 by Densore, Green, and other colleagues. So now LMX leads to identification. Now, see what I'm proposing. If you have good quality relationship with your leader, you tend to identify with your organization. And if you identify with your organization, you tend to engage in citizenship behavior towards the organization. Yes. So if you're, see, again, the quality of relationship that you have at the workplace will determine a lot of outcomes. So if you are in good quality relationship with your boss, or if you're in good books of your boss, you tend to identify with your organization. If you identify with your organization, you tend to engage in citizenship behavior towards the organization. So there is one direct effect, LMX. LMX leads to OCB. This is a direct effect. And this is your indirect effect. Yes. So there is one path which goes from LMX to OCB. And there is one path which goes from OI to OCB. So it means here OI is a mediator in the relationship of LMX and OCB. So there is one direct path. When I say direct path, this is your LMX OCB relationship. And when I say indirect path, it is LMX OI OCB. This is your direct path. And this is your indirect path. Okay. Now I'll tell you one interesting thing. Then I'll proceed further. Specifying a model. When I say specifying a model, model specification, let me write a term here, model specification. Model specification. Model specification is nothing but you are drawing a model. You are showing a relationship between variables. LMX leads to Y, Y leads to OCB. This is your model specification. Now, model specification is damn easy. You can identify any two construct, three construct, four constructs and fit the relationship between them based on literature and all those things. But the biggest question is that which theory explains this particular model? Theory. Yes. See, on many occasions you come across this term, that is theoretical framework. Let me talk slightly in detail. Theoretical framework and conceptual framework. What are they? In fact, I come across these two terms quite often when I read papers. theoretical framework and conceptual framework. What does it mean? Anyone? The floor is open. There is no wrong answer. Yes? Now, I, as a researcher, I say LMX leads to OI, OI leads to OCB. Now, which theory explains this model? Now, if you want to publish a paper or you want to write a paper, you see a model from the lens of a particular theory. So if the theory is missing, no matter how much analytical rigor you put into your paper, the paper will not carry weight, because data analysis is not something that is going to help you publish or contribute to the literature. Getting? So it is your contribution to theory, something addition to the theory or validation of the theory or seeing a theory in a new perspective will help you to contribute to the theoretical implication part of the paper. Now, the difficulty is that I've heard this from many seasoned professors, that specifying a model is not a big deal. Anybody can specify a model, identify constructs and build a relationship based on literature review. But when you build a model, you require certain theory to explain that model. That when you say LMX leads to OI and OI leads to OCB, which theory? Now, from here, you can make it out that there is something known as leader-member exchange theory. Leader-member exchange theory. Again, this theory came in 1975. And then one is social identity theory. Social identity theory. Vishal sir is there? Hello? Manishi, Vishal sir is there? Hello?
Yes, I am here. I am here very much.
Okay. So now see, specifying a model is not a big deal. People specify, people review literature and they identify the positive relationship with the model. Now the question is, which theory to fit in? Which theory to fit in? That itself is a big challenge. So again, the question comes, theoretical framework and the conceptual framework. Let me open the floor to everyone. How do you differentiate between a theoretical framework and a conceptual framework? Come on, it's always a difficult question which I have asked in many of the workshops, and sometimes I have not get a decent answer. Okay, what's the difference between a theoretical framework and a conceptual framework? The floor is open. There is no wrong answer.
Can I say something, sir?
Yeah, go ahead, Satish. Go ahead. Yes.
Yeah. Sir, when it comes to theoretical framework, whatever literature we review, so on the basis of certain theories which we highlighted and which we relate somewhat to our variables or construct. And now suppose we are having some, novelty. That means if we are putting some new variables into the existing theoretical framework, or we are
Okay.
trying to club, 2-3 different variables from 2-3 different theories or the different, paradigms, and we are trying to bring a new concept or a new theory in my mental, the framework, and then I'm putting it into trying to connect the conceptual framework, relating it to the theoretical framework, and back and forth, I'm trying to examine the relationship between theory and my mental process and the conceptual network. So that is what, the relationship between theoretical framework
Okay,
and
Satish
conceptual
ji,
framework.
okay. First of all, there is no wrong answer. I appreciate that you spoke. If you want to explain Ola to a kid in one line, how would you explain?
Pardon, can you
Explaining,
repeat, sir?
if you want to explain Ola taxi ride to a kid, let's say 5-year kid, how would you explain in one line? As simple as that. So simply, see, okay. So anybody else would give a try? Difference between theoretical framework and conceptual framework. There is no wrong answer. Okay.
When we have
Ashish, go ahead.
relationship of construct, then we can say this is conceptual framework. When we
Okay.
relate construct with particular theory or two or more theories, then we can call like a theoretical framework.
Okay, Ashish. Okay, fair enough. Anybody else would give a try? Anybody else would give a try? There is no wrong answer. Yes, go ahead.
Maybe if the framework is already based on existing theory, supported by existing theory, proven theory. We may call it a theoretical framework. And the other
Okay.
case, the framework is yet to be tested and proven. So it remains in the domain of
Okay.
conceptual framework till the time it is well established and accepted worldwide.
Okay, okay, okay. So let me add my view on this. I don't say that this is the right answer, but the floor is open. Yes. See, now again, I said, see, data analysis is not a big thing. Times will come where you put your Excel into some software, and the software will give you a number of models with all the validity testing on the path relationship. A time will come. Yes. But the question is that when you are positing constructs against each other, what are the theoretical underpinnings? So if you focus on the model which I have specified right now, I say LMX leads to OI and OI leads to OCB. So here I'm building my argument or my model on two theoretical frameworks. I'm using two theory to explain this particular model. One is leader member exchange theory. Yes. And second is social identification theory. Let's say if I'm in the good books of my leader, I will tend to identify myself with that particular organization, because identification leads to categorization. Identification leads to categorization. And if I categorize myself favorably, yes, I tend to engage in certain beneficial behaviors which will help the organization. So if you focus on this particular model, the theoretical framework is LMX and social identity theory. Theoretical framework, it means which theory you are using to explain your conceptual model. Does that make sense? Does that make sense? Again, I'm repeating, when I say theoretical framework, it means which theories I'm using to explain the relationship that I have built in the model. So that is a theoretical framework. And when I say conceptual framework, it is the model that I'm proposing. Yes. And of course, that model will be linked to certain theories. But in my little understanding, I say conceptual framework is the relationship between the variables. So that's why when you come across research papers, you see that conceptual model. So conceptual model, you can take it as a conceptual framework, but that conceptual model should have theory underneath it, which explains the relationship between the variables. As simple as this. This is how I have understood. Vishal sir, can you build upon this? We are very
I think what you are saying is right. And we can also consider theoretical framework as if as a framework comprising of constructs, right, which have well-grounded backing and logic. So conceptual framework, we can also say, is we have just linked 2-3 constructs together. So for example, LMX, OI, and OCB is a conceptual framework where we have linked these 3 constructs, and this is my conceptual framework. But this conceptual framework has an underlying logic. What is a theory? Theory is nothing but a set of interconnections between constructs which are theoretically, logically backed, right? Which make sense, which are logical. So theoretical framework, you can say it's like the foundation on which the conceptual framework is built. It provides us the logic, it provides us the uh, rationale for why these 3 constructs should be connected to each other.
Fair enough. Thank you, sir. Thank you. Thank you. We are almost on the same page.
Yes.
In fact, I always have this confusion that theoretical framework and conceptual framework. I thought I'll take this.
Yeah, and in research papers, we typically say, as you also said, conceptual model, conceptual framework.
Okay. Okay.
Right.
So this is one model that we have proposed. And if I take you to my slide, so actually this model is nowhere to be found in any of the literature. I just drew this model on my own understanding that notoriety leads to success. But before
So it seems Arun's connection, I think, has broken. So we'll wait for a few minutes. Arun will come back. Yeah. Let us wait for a few minutes. He will join back. What we can also do, everybody, we can take a break for 15 minutes and we can return at 4:15. So we can take a break now and we will join back at 4:15.